Hello everyone. So this video is going to be an introduction to sinusoidal functions. Sinusoidal functions are functions that graph sine of theta or cosine of theta, hence the name sinusoidal. Before we discuss how the graph looks like, let's consider a unit circle. A unit circle just means it's a circle that has a radius that is 1 unit long. So if I'm gonna draw that, that would just be like 1 unit. The radius of that circle is 1 unit long, and the center is right at the origin. Okay, so this would be my initial arm, and that initial arm normally rotates in the counterclockwise direction this way, moving all along the actual circle. Okay, so if I have that anywhere, I can actually use my knowledge of primary trig ratios to calculate the height of that point. So whenever it moves, it creates a theta, it creates an angle here. That theta can be used to find the height. Okay, so my primary trig ratios follow SOHCAHTOA, meaning that if you have a right triangle, an angle theta, the sine of that angle, so considering so first, sine of that theta is opposite over hypotenuse. We know that this is my hypotenuse. That is the side that is opposite to theta, and this side right here is adjacent. Cosine theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. Okay, these are my primary trig ratios. If we were to graph height versus theta versus the angle, then it would be 0, 0. When the angle is 0, the actual height is 0. Also, the other obvious one that we can create is here. So right when the angle is 90 degrees, my height is, because it's a unit circle, so you know it is 1 unit long, so we know that my height is 1. This one is 1, which means that this one has to be -1. And then it continues to rotate, so my angle right here, just keep in mind that my angle keeps getting larger and larger. So we're always starting from this initial arm and then extending to wherever it stops, so the terminating arm, wherever it stops. So if I continue and make this straight line angle, this will be 180-degree angle. So at 180 degrees, my height again is 0. Then I can continue to rotate my arm here, and I know exactly at 270 degrees. So right here, this is 270 because it is 180 plus 90. So my angle right here is 270 degrees. And right at 270 degrees, my height is actually -1. And then back, if it continues to rotate and it goes back to 360, meaning that the angle started at this point, it rotated and came back here. So the total theta, or the total angle there, is 360 degrees. Okay, so here is my angles. My angles have to go up at a consistent rate, like that's how we graph anything. So if I decided I want to go up by 90s, it went up by 90s all throughout. I have these major points that I can graph because I know what they are. The last one is that if we have it 360 degrees, then my height is 0. This is the overall look of my sinusoidal function. We haven't verified yet the fact that it's curved. So the fact that it's more like a wave instead of being like a straight line. But that is the case if I was to check all the heights throughout, like for 30 degrees, for 60, for 45 degrees, for 60 degrees, it tends to take this shape. That is the graph for sine theta. Okay, so let's look at this curve and verify the values of that, just to verify that it's an actual curve and not a straight line. So if we are to determine maybe 30 degrees, 45 degrees, and 60 degrees, we already know what the sine is for 0 and for 90. If right here it's 30 degrees, and we're trying to determine what the height would be, just remember that it's actually, the ratio is so, meaning sine theta is opposite over hypotenuse. So it's theta, in this case, it's 30 degrees. The opposite is what we're trying to figure out, which is the height, because ultimately that's what we're graphing. And hypotenuse is 1. Okay, it's because it's a unit circle. So this is 1. Here the opposite, 1/2, 1/2. You can plug it in the calculator, or these common angles like 30, 45, and 60. At some point you need to learn them. There is an actual hand trick for it. You can look it up. It will really help kind of memorize it. Okay, so here is sine 30. And then if you do the same thing for sine 45, the exact value of the opposite is actually 1 over square root of 2. And then for sine 60, it is the square root of 3 over 2. If I was to plug in the calculator, it's going to be 0.71 0.87. Okay, so on my actual graph, halfway through would be the 45, and that would be 0.7. Cannot be too exact. This would be half. This would be my 30, so right here is the half, and right here we would have 0.87, close to 0.9. So you'll realize it's an actual curve. That is a sinusoidal function, or that is part of a sinusoidal function. That is y equals sine of x in this case. This sinusoidal function is periodic, means it will repeat that same cycle again and again. Okay, so this is a cycle, and that cycle landed where it started from. So if it starts here, it ends right here, and that's a full cycle or a full period. It will continue to create those same waves. This is a period. The period of this cycle is 360 degrees. It will go a full cycle every 360 degrees, and then it can continue to rotate again and again. We also consider something called the amplitude. The amplitude is the axis right here to the highest points, or from the axis to the lowest point is the amplitude, and the amplitude here is 1. It is the same as this distance. It's 1. Amplitude is 1. Period is 360 degrees. The equation of axis is the middle line. How can we get the equation of axis? You get the maximum point and then the minimum point, and find what is the line that goes halfway between the two. Okay, so let's also note down that the max here is 1, and the minimum is -1. The equation of axis, how do we determine that? We add up the minimum and the maximum and divide by 2. Okay, in this case, it is 0. 0 divided by 2 is 0. In this case, is 0. So the equation of axis is an equation. So you have to write it as an equation. It's y equals 0. Okay, right now, it might seem a little obvious to kind of like, why are we even mentioning it? But then in other graphs, ultimately, when you talk about different types of that graph or the transformations of that graph, this whole graph could shift up or down. So the equation of axis itself is going to be shifting up or down, translating vertically. Okay, up or down, and then that way it changes, and that way it matters when you add the maximum and the minimum, and it will give you a different number than 0. Okay, so this is a sine graph. Cosine graph can be determined in the exact same way. Okay, except the cosine in a primary trig ratio involves the adjacent and the hypotenuse. So you will end up with a slightly different graph, or the same graph or a similar graph that is being translated or shifted. Okay, so for cosine, the primary trig ratio in SOHCAHTOA is adjacent over hypotenuse. So cosine of theta equals adjacent over hypotenuse. So we are no longer considering the height here. We're considering the distance away from the y-axis. So here, theta, that would be the adjacent. So it's how far away is it from the y-axis. Okay, so we do know a few points here, so we can do a rough sketch. So right when we start off, when the theta is 0, when the angle is 0, the actual adjacent side is 1 unit. It is not 0, it's 1 unit, because we're talking how far away is it from the y-axis. It's right here. It's that far away. So it is 1 unit. And if I want to plot that here, that would have been right here at 0. And then if I rotate it, the other obvious one is when theta is 90 degrees. So right here, my theta is 90 degrees. Right when it's 90 degrees, my adjacent side becomes 0. And then if I continue to rotate this way, and at 180 degrees, we want to consider 180 degrees, and then 270 degrees, and then 360. Okay, so at 180 degrees, the adjacent side is -1, meaning it is on the opposite side, so it's -1 away from the y-axis. And then it will continue rotating. And then right here will be 0 again, my adjacent side. And then back to where we started at. You are having an adjacent side of 1. Okay, so right here it's also a curve. Consider 30 degrees, 45 degrees, and 60 degrees, and the cosine of that. And just plug it in the calculator and get the answers. But the exact answer would be the square root of 3/2 for 30 degrees, and then it would be 1 over square root of 2, just like for the sine value. And here it will be half. If I have my calculator right here. and it is 0.87, 0.71. That's my y, and that's my x. And then right at 60, it should be halfway, okay, which is fine. Kind of works that way. This is -1. And then right here, it is going to be at the exact same point as the sine, which we looked at in the other graph. And for 30 degrees, it will be very close to 0.9. That verifies that the cosine looks like this. This is y equals cosine of x. It's just slightly different than the sine. Just remember those graphs. You continue. So if I was to continue graphing it, it will continue to go down and then back up at the same intervals forever in both directions. This is how my cosine looks like. You have to always remember that the cosine meets the y-axis, or the y-intercept of the cosine is 1, and the y-intercept of the sine is 0. So if I was to graph them together, looks like this. Okay, it's the same graph, but it's shifted. It is translated. Also continues in both directions. That is how both this is y equals sine of x, my sinusoidal functions look like. This is the very basics of it. It also assumes that you know a little bit about primary trig ratios, and there's a little bit more to this when we talk about transformations and what happens when the graph is being translated or being stretched in any way. So one last thing, this cosine function again has a period of 360 degrees. That means it finishes the full cycle after every 360 degrees and then undergoes another full cycle. It also has a maximum of 1 and a minimum of 1. The equation of axis is also y equals 0. In the previous one, we didn't talk about the domain and range. So the domain here will go on infinitely in opposite directions. That means it could be any real number. Domain x is a real number. And then the range is also a real number, such that y has to be between greater than negative or equal to -1 and then smaller than or equal to +1. So that's basically the sine and cosine function. It can resemble real life situations. We are talking about this rotation. So that rotation happens in real life, and sometimes scientists do need to graph it. The application type of questions that you might see here, you might be talking about the Ferris wheel and something moving along the Ferris wheel, and you need to graph it. You might be talking about a nail that is stuck in a wheel, and then that nail moves along the wheel, and you had to determine a graph for it. So these cycles that happen again and again in a periodic way, and that follow the sinusoidal functions, come up again and again in math and physics. Hey, thank you so much for listening. I hope this helped.